So continuing on with our notes, we're going to talk about trigonometric functions. So basically putting this all together, why are we talking about these circles? Why are we talking about the angle measures? Okay? So basically, let theta be an angle in standard form, and P of xy be a point on the terminal side of theta. The distance from P to the origin R can be found using the formula. So let's talk about this. So all of what we've been talking about is on a coordinate plane. Now on the coordinate plane you have points, right? You can plot points on the coordinate plane. You can take any point on the coordinate plane and connect it from the origin, the center, to the point and make a line. And we can find the coordinates of this line, or the distance rather, of this line by using Pythagorean theorem. X squared plus y squared equals r squared, right? So you can either write it as, you can write x squared plus y squared equals r squared. So a squared plus b squared equals c squared. This is a, b, and this is c. Does everybody see that on the picture? What I'm talking about. And we can also use our trig functions to figure this out as well. So sine is opposite over hypotenuse. So what side is opposite to the angle theta? Anybody know? What's that side? Y over the hypotenuse, which is r. Does everybody see what I'm talking about for that triangle? Which means cosecant is the reciprocal of that, r over y. Now cosine is what over what? Anybody know? Adjacent over hypotenuse. So the adjacent side to theta is x over the hypotenuse r, which means secant is r over x. And tangent is opposite, which is y, over adjacent. And cotangent is opposite of that, which is x over y. So does everybody see where I got those fractions from, looking at the picture of the triangle in terms of theta, using trig functions? Okay. So let's now do some examples with this. Given P lies on the terminal side of theta in standard form, define each trigonometric function in terms of theta and state the associated reference angle. All right, so we have a point. So think of the point 3, -4. If this is a coordinate plane, where's that going to be? So we would go over about 1, 2, 3, and then we would go up or down to -4. You guys don't know how to graph a point in Algebra 2? Down, thank you. So we go over 1, 2, 3, and down 1, 2, 3, 4. So this is the point 3, -4. So does everybody understand how I knew that it was around this point? It's an estimate, okay? Doesn't have to be perfect. Once you plot that point, you're going to connect the origin to the point. Now we're going to finish making our triangle. So you remember the bow tie thing I showed you, the bow tie method? We're going to follow that. So we're in the 4th quadrant, so it's going to be like this. Going to make that bow tie piece for the triangle. Now we need to find the length of these sides. So we went 3 units over, this is 3 units, and we went -4 units down. Now I recognize that distance cannot be negative. We all know this, right? But this is more symbolic of the direction that we went. So while this is actually technically 4, we went down 4 units, so the negative is symbolic of the direction that we went. All right, so that's why it's negative. I know it's not really negative. And now that we have this, can we use Pythagorean theorem to find the missing side, which is the hypotenuse? Yeah. 3 squared plus -4 squared is equal to r squared. That's 25 is equal to r squared, which means r is equal to what? 5. So we just found our hypotenuse, right? So now we'll continue on with the rest of the notes. So theta will always be the angle that's close to the middle Alright, never this one. It's always the one close to the middle. Now that we have theta, we can do our trigonometric functions. Sine is opposite, -4, over hypotenuse, which is 5. Cosecant is the reciprocal of that, -5/4. Cosine is adjacent, which is 3, over the hypotenuse, which is 5. Secant is the reciprocal of that. Tangent is opposite, -4, over adjacent. And cotan is adjacent over opposite. So does everybody see where I got those from? Now, every time you do this, unless you're in the first quadrant where they're all positive, any other quadrant, one pair of these are going to be positive. Does everybody see that one pair that's positive? The cosine and the secant? That's the one you're going to use to find the reference angle. Okay, the one that's positive. There's always going to be at least one that's positive. That's the one you're going to use. So what you're going to do is you're going to have to find the angle that corresponds to this. To find the angle when we have the sides, we do inverse cosine of 3/5 is equal to theta. So you're going to use the second button on your calculator. Okay? So on your calculator, you would do 3 divided by 5. And then second cosine. And you should get a degree of about 53 degrees. So that's how you do a reference angle, okay? Use the inverse. You always use the inverse when you're looking for the angle. So is everybody good with how we got that? Yes.
I got a different number.
Are you in radian mode on your calculator?
Radian?
By any chance?
I'm on.
Does it say rad or degree on it?
Yes. Yes, it is.
Yep, so you don't want it to say rad, you want to click degree. Because what you were doing is plugging in radians, and then that was giving you a radian answer. So if you 3, that should work now. So make sure your calculator is in degree mode when you do this, okay? So is everybody good with A? Are we good to move on to B? So over here, we're going to plot our point. So -3, 1, 2, 3, and then up 1, 2. It's going to be somewhere over here. You're going to take that point, you're going to connect it to the origin. Create your triangle. Make sure it has that bow tie shape. You don't want it to be up here, you want it to be down here. We went -3 in this direction and up +2. So those are our two side measures. This is theta, the angle that's in the middle there. 2 squared plus -3 squared is equal to r squared. That's 13 is equal to r squared, which means r equals the square root of 13. You can't do anything with that. You're going to leave it as the square root of 13. Everybody understand how we got that, square root of 13? Now we're going to do our trig functions. Sine is opposite over hypotenuse. The reciprocal of that is radical 13 over 2. We have to rationalize this because the radical is in the denominator. Multiply the top and bottom by radical 13, which comes out to be 2 radical 13 over 13. We're going to move on. Cosine. That's going to be adjacent over hypotenuse. We take the reciprocal of that, but we have to rationalize this. So this rationalizes to -3 over times radical 13 over 13. And then we'll do tangent. Tangent is opposite over adjacent. We always put our negative on the top. Cotan would be adjacent over opposite. So does everybody see how I got those 6 values from what we've been practicing so far? All right, now we're going to identify which of these pairs are positive. Which of these pairs are positive?
The top one.
The top one. This is the one we're going to work with for our reference angle. Find the one that's positive. Now, my suggestion when you find the reference angle, you're going to do sine inverse of. I like to use the one before I rationalized. You can use the rationalized one, you'll get the right answer, but the math is a little easier if you use the rationalized version of the fraction, okay? So we're going to use our calculator. 2 divided by 13 square root equals, and then second sine. And that will give you the angle measure of 34 degrees. So that means this angle right here is 34 degrees. That's what we just found, the reference angle, when we do that math, okay? So does everybody understand what we've done so far today? All right, so you have about 30 minutes or so to do some homework.